So there actually nothing was in motion. So maybe I'll say no velocity or no movement of one body. So that was the case. But here in explicit, we will have a motion, or maybe we will have bodies moving with respect to each other. So that's what will be happening in explicit analysis. So here we will going to solve this equation, like force is equal to my mass into acceleration. So here my deformation term has been replaced by the acceleration, and the stiffness term, it has been replaced by my mass matrix. Okay, so this is the basic difference between two calculations. So again, we will see. So here we will have a lumped mass if we just use lower order elements, maybe uh, lower order element and higher order element. Basically, we have, maybe if I'm having a 1D element, so maybe this bottom you can see, if you assume this as one element. So in lower order element, what is happening? Like one node is at like this position where I'm having my cursor, and second node I'm having at this position. So that's the lower order element. But what happens in higher order elements? So in between those two nodes also, I will be having some nodes. So that's nothing but higher order. If I'm having tet element, maybe 2D tet element. So in that case, I'm having three corners in triangular, maybe like such type of triangle. So I'm having three nodes at three junctions. But in case of higher order elements, so in between each edge, I'm having extra nodes. So in total, like six nodes I will have. So that is my higher order element. So that's simple difference. Uh, Maybe here for convergence, we use such methods like Newton-Raphson's method, and yeah, the matrix solver methods we use over here. Here actually, this is like means disadvantage is that like this time integration means that is not used. So it's stable we can say. There are very little convergence issues. Issues only come because of its time. Maybe if we have defined like extra times. So here the last point, it says we need to use very small time steps. If we use like higher time steps or a longer duration for solving, so it may have some issues in that. So yes. Again, in explicit short time for solution time steps. So this time we have to define, it's in like maybe milliseconds or microseconds, like that. uh, okay, again, non-linearities deformation, we can check it, means consider over here material properties, and like non-linear material properties we can check, and even contacts also we will define, those are non-linear. So let's see applications where basically it is required. uh, so maybe you must have seen such crash tests, so that you can perform by using explicit dynamics. So basically you can create the model of car and model of such wall, and you can do such kind of calculations. Again, free falling, maybe if your mobile phone is fall down on the ground, so that calculation also you can perform, like by using this explicit analysis. Again, explosions, or maybe some cases of two vehicles having some accident. So okay, so such cases you can do. Again, the manufacturing processes. So maybe such kind of manufacturing processes you can simulate, and you can simply have the end results. So, so this everything can be happen or may be possible by using explicit dynamic calculations. Again, in terms of like a nuclear, or maybe some research going on. So CERN is nothing but one of the organization in Europe. They are dealing with finding some highly moving particles, some electromagnetic particles, and with the help of them they are trying to generate electricity. So something like that. So they are using over there variety of fusion processes. So there actually that type of calculation also can be possible by using this explicit dynamics methods. uh, Again, we have ls dyna, a separate software. It's pre-built in Ansys. So that also in that also it is possible. And the one we will be seeing today is like Ansys Heterodyne. So here it's inbuilt in Ansys. It's like both the licenses are there, but we will be seeing this Ansys Heterodyne. Fine. So you got a rough idea. So what basically difference between these two, and why it is necessary. So in case if you have some motion, or maybe if you want to simulate interaction between two bodies, so maybe some accidental case, or maybe some tests, or something falling freely. So here again two bodies are there. One is my floor, and this is my mobile phone. So if such cases are there, then there we need to use such explicit dynamics kinds of things. Okay. Let's just see our today's problem. So here we will be simulating this projectile, basically projectile of a bullet. So this is nothing but my bullet. So that bullet is moving with the speed of 221 meters per second, or 221,000 millimeters per second. And yes, that we need to model. So we need to assign the material for this bullet. So that's nothing but my concrete wall, and I need to fire this bullet on the concrete wall. And I need to check at the end, like how the behavior of my bullet as well as my wall is. Okay, so at what distance my that wall is. So that wall is at 10 millimeter distance. Fine. And 10 millimeter distance from my this bullet tip, and that will be the fixed point. Okay. So maybe I'll just open the workbench. Let's just import the model. So here basically I will show you like how we can model, and maybe the other part remaining from that. So I can show you this part also over here, and so how we can select these nodes. So the nodal selection basically. Okay. So now here, instead of static, structural, or maybe a transient, I'll simply go here. One tab is there, explicit dynamics, you can see. So now I'll simply double click on that. So that is my explicit dynamics. So before that, maybe we have a non-linear material. So let's check. We have a concrete non-linear material. Okay. And for bullet, I will define maybe material in steel category, but that to non-linear material. Fine. So engineering data. So now I will go to general non-linear materials, and maybe I'll select one with the copper concrete non-linear, and second maybe I'll just check the stainless steel non-linear. Okay, that will be my bullet material. So now just go to the geometry. Let's open the new geometry. Okay, now just set its units to millimeter, and let's import the model. Okay, so I'll simply import the bullet model. Let's generate it. Okay, so what I will do maybe over here, we will see how I can make modeling of this wall. So maybe uh, I will simply delete for the moment this part. So just for our learning purpose, I'm showing like how I can model the wall, that to at 10 millimeter distance from the tip. So maybe what I will do, I will try to create one new plane. So here I have some options. So here maybe I'll select maybe from centroid. Let's check how it takes. So base entities, go here, go into the face. So let's say apply. So okay. So can you see that my plane, it has come over there at the centroid of the face, whatever I have selected. But actually I want on the tip. I'll try. If not, then maybe I can move it also. Let's just check with whether we have any other options. Maybe face. Okay. this face has given me, but you can see its orientation is not same like my global coordinate system. So I guess centroid will be good option over here. So let's say generate. Okay, so now, so you can see my x is my red, y is my green one, and z is my blue one. So I want actually xyz plane in this way. So whatever I will draw, that will be in xy plane only, xy plane of my local plane. So again, this is my global coordinate and this is my local coordinate. So I will be making sketches in local coordinate system, and in that too, so I will only make my sketching in xy plane. So here that too in xy plane, but what I need now, I need to create wall in such a way. So maybe currently a yz plane. So for that actually I need to rotate this one so that my x will come this way and y will be vertical. Why? Because here in design modeler, I can only sketch on XY plane. So none other plane. So XY plane of local coordinate system. Okay. So what we will do now, we will try to rotate this plane, and we will try to get x-axis as like I am having Z now, and my Z in that case will come at my x-axis location. Okay, so maybe let's just go to same plane, say edit. Here I have one option, transform. So let's just go over there and say rotate. So which axis I have to now rotate? I'll say y-axis. So this y-axis I will rotate by 90. Then my x will go like this and y will come like this. Okay, so I will say maybe 90. Got it. So why I did this? Because I will have only sketching only possible on XY plane. X is red and Y is my Z color, green color, red and green. So only sketching is possible on XY plane. That's why I rotated it. Fine. Now we can move our coordinate system. So in this direction, so local coordinate system if you see in Z direction, and global if you see in X direction. Fine. So maybe what I will do, so I will again go to this plane. So right click and say edit. So now I am into local coordinate system. So I have to follow this one. So this is my blue color means Z axis. Okay. So again I will go to second transform. So here what I will say offset Z. So maybe here in bottom you have ruler. So you can also make use of that ruler. So I want this coordinate system near about at this location. So what I will do, maybe somewhere 0.15. So it's somewhere between zero point 0.1 to zero point 0.2. So maybe I'll say this offset distance at 0.15. Can you see? So my is just maybe away from the tip. Maybe I'll reduce it by, or maybe 5, or maybe I can say it's 4. So let's go with 0.14. Okay, so I'm having coordinate system exactly at the uh, tip of my bullet. So what it has shown over here, so 10 millimeters away from the tip of my bullet. So now what I will do, I will simply add 10 millimeters into it. So I'll say 10 plus. So you can see now where I'm having. So I will have my wall, which will be situated at this location, and I'm having this bullet. And now in my calculation, my bullet will be running in this direction with a velocity of 211 meter per second. Okay, so until now you got it. So I'll say generate. So now what I will do, I will click on this plane, and here I will click on sketch. So what will happen, so my xy plane will be in operation then, and I can just make whatever sketch on that plane. Now you see, so you can see this as a dotted line. So what it has it has shown me, so my this plane is now ready for my sketching. Okay. So what I will do, I'll simply go on this xy plane, I'll zoom it a little bit, and maybe I'll select the rectangle because I need to model the wall. So I just made something like this. So that much size wall is sufficient. So now I will simply click on this extrude. Otherwise, I can just come back from sketching. So here it's sketching and here it's modeling, right? So I'll come to the modeling part. I'll say extrude, and what I have to extrude, I'll open this plane and I'll say this sketch one. So this is my sketch one that I have to extrude. So I'll say apply, and maybe I'll simply use 1 millimeters or 0.5 millimeters. Fine. So this much thick wall I will need. I will still reduce its thickness. I said generate. When I say generate, my wall will be created. So got it. So now I have the bullet and I have the wall also. Now I'll simply go to the model. So we have already defined two nonlinear materials, nonlinear stainless steel. And here in geometry, I have shown you some part how we can model some things in design modeler. Now I'll be simply taking the model into the mechanical. Okay, we are now into the mechanical. Just check. This is nothing but one number is saying for bullet and solid. Uh, it is for my wall. So let's just make my window layout a little bit bigger. Okay. Okay. So just assign the materials. So instead of structural steel, maybe I will say a stainless steel. Instead of this structural steel, here I will say concrete. Okay, fine. So now what I have to do, I have to assign the velocity for this bullet, and I have to make a fix. I have to fix that wall. Okay, so that to my velocity on the bullet will be in x direction. So my this bullet will travel in x direction. Fine. Okay, let's just assign it. So maybe just open this initial condition. So here you can assign the velocity. So maybe before that I will check like how I can mesh. So I simply right click and set mesh. So it has generated for me a default mesh, and I think that's okay. So let's just then open this initial conditions. So here if I right click, then I can assign either velocity, linear one or angular one. I want a linear velocity, so I'll simply click on the velocity. So it is asking me a geometry selection. So here I'll select the body because my whole body will move. Okay. Now the velocity. So let's just check the velocity. So maybe I will copy this number. So 211000. So you can see how much this velocity is. So that in millimeter per seconds. 221 meter per seconds. If we just take those in terms of meters per seconds, and direction I have to define. So I can define either by selecting this face, a perpendicular face, and you can just flip the arrows from this one. So this is possible. Second, you can select even the cylindrical face also. So this will also give you the direction. Okay, so currently I will be selecting this face, and what I'm saying, so perpendicular to this face, so which will be in x direction, like this. Then I'll say apply. So now you can get, so this is from CG of my body, whatever my bullet body is, and from CG it is showing me this one arrow. Okay, so velocity part is complete. I have defined the velocity. Now, my second part should be I need to fix this wall. So what I will do, I'll simply right click and say fixed support. So now I will have a fixity on maybe these four faces. So I'll simply select them for all and say apply. Okay. So uh, you can see now my application of velocity for this bullet, it's complete. My wall, it's fixed. Now just go to the analysis setting. Now you have to define the end time. So this is only a little bit new thing than what we haven't seen previously in our earlier calculations. So here you have to define time. So basically, velocity is nothing but distance covered per unit time. So whatever distance my bullet will be covering divided by a time, so that will give me velocity. But currently, I am having the velocity, that number I am having, and the distance also I am having. So it's roughly around 10 millimeters. So it's roughly around 10 millimeters in between this bullet and this wall. So what I will do, maybe let's calculate what time we just need. So what is velocity? Velocity is nothing but distance covered per unit time. So now I have distance and I have velocity, but I don't have time. So I can calculate. So distance covered will be 10 millimeters, and my velocity is 21100 millimeters per second. So you can see 4.7 into 10 raised to minus 5 means around 5 into 10 raised to minus 5. Okay, so that much time my bullet will be required there, or maybe you can say 0.05 milliseconds. So that much time will be required for my bullet to travel this much distance. So in milliseconds. So maybe I will define a little bit, so sometime maybe more than this. So what I want to simulate, or maybe on the this one, so this is my required time, and I will simply go maybe a 4.8 or 4.9. So that in that case I will able to simulate so whatever impact over here. If I just define lesser time than this, then maybe my bullet will be somewhere in the middle, so it will not reach to my wall. Okay, so I will define my time a little bit on higher side, but not too much. If I define here like 1 second, so that will be very huge time. Like this is in the order of like e raised to minus 5. If I define 1 seconds, then it's very very high time as compared to this one. So in that case, maybe my solution will take a lot of time to solve, or maybe some other problems will occur. So be cautious while defining your time. So maybe let's check whether I can copy it. Yes, I can copy it. So let's just put this. Okay. So what I will do, maybe I will define 5 instead of 4. Okay, so my time, you know what I did? I simply calculated the time required for my bullet to travel from this distance, this place to this place, and I defined somewhat higher time, so that I can simulate what after this. So after this, if my bullet will go through this or maybe hit to this body and stay over here. So for that, I have defined a little bit extra time. So instead of 4.7, I have defined 5.3. Okay. So now I simply go on to the solution. So my part is like modeling setup and defining boundary condition is complete. So two important points to mention over here, like you have to define your velocity, you have to make fix this, and second one is defining your time. So end time. So that's important. So only these two factors. If you do correctly, you will solve this explicit dynamics problem. So just right click and say solve. So okay, maybe when this solve will done, this will take time because this is explicit dynamics, so non-linear type of calculation. So in between, maybe I will show you how you can select the nodes. So, oops, sorry, I have opened it in read only mode. Maybe I need to open it again. Let's wait till it opens. So the one we left from our earlier assignments, the only one point, so that we will see, so how we can simply Okay, now it will be open. So the one I'll open. So from last assignment, so the only one portion left was so selection of these nodes. So we have seen like we can apply pressure on all over the face. But what in case if I need to apply on maybe certain nodes? So how we can do that? Maybe we can see it over here. Okay, so let's just check where I'm having my global coordinate system. So this is my global coordinate system. Okay, fine. So now what I will do, I have to select whatever above this z-axis. So I need to select only this portion of this space. So what I have to do, I have to select all the nodes above my z-axis, or maybe whatever in plus y direction that I have to select, and whatever in the minus y direction that I want to exclude. I don't want to include it into my calculation. So what I will do, I will simply click over here, say right click and say create named solution. So that we have seen, that we have seen. So now I'll just go here, selection, go to selection. So until this we know from our earlier sessions. Now just right click on it and say create nodal named selection. So you will have that nodes over here. Got it? And you can see this table, you can see, maybe I'll make it little bit large, maybe somewhere here, and just click it. Okay, maybe I will also leave it. So when you have this kind of node selected, so you will have such thing. So here you can see what difference between these two. So here on this selection, if you go, so here you will see scoping method as geometry selection, and you will see one face. If you go here in the nodal selection, you will see here scoping method is worksheet. Worksheet is nothing but this one. So worksheet, and there I am having 784 nodes. Okay. So now what I can do over here, what I need to do, I need to just select nodes who those are in plus y direction. So I will simply right click over here and say add row. Now what I have to do, I have to filter. So here you can basically add nodes, you can remove, you can filter, invert, and convert. So convert, here you have first consider in first row, you have that face, whatever we have selected over here. And in second, you have simply converted that face into my nodes. So you can see convert to mesh nodes, face convert to mesh nodes. Now I have to filter whatever nodes I am having, filter in positive y direction. So I will simply say, instead of add, I will say filter, and again mesh node. Now what I have to which nodes I need to have, location y. Okay, operator is greater than, so whatever on y greater than 0. If I just selected less than, then less than 0 means all the nodes which are in negative direction, those are selected. So greater than value I will put 0. Okay, so that's the global coordinate system. So what I have like that, you can correlate these things and think of that how much time will be required in that cases, and how much bulky your work system should be to solve such kind of problems. Fine. So maybe our second problem has solved. Yes. So our this roll cage problem, it has solved. Let's just right click and say stresses equivalent, and right click deformation and say maybe directional one. Say evaluate. Okay. Maybe I can hide or I can make off the mesh and say reset one. Okay, so what is happening over here, my roll cage, it's moving in this direction and hitting onto this wall. Actually my wall size is little bit means thin one, I guess. One, it wouldn't have deflected, and all the things like my this roll cage would have deflected. Okay, so maybe I can simulate it. So how you can see how my roll cage it's moving, and you can see how it's hitting my wall and how it's behaving. Even you can simply check the equivalent stresses. So you can see stresses are generating at the impact point. So at here, can you see? So if you would have modeled this wall little bit in thick side wall, and maybe if you would have defined any rigid materials on this, so you would have seen only deformation on the wall, on the roll cage, not on the wall. Okay, so I think that's what we have for this non-linear analysis. So the third one is a simple one, so we can exclude that. So we have solved these two problems, and even we have solved this one for explicit dynamics. So yeah, let's see whether our earlier problem has solved or not. Yet it's solving. Okay, meanwhile, if we have any questions, we can take up that. So, as we will be having only one session after this. So, if anybody has tried something and if they want to share their experience or if they want to ask any query, so you can please ask now. So, we have some time, so you can ask me those questions. So, first question is like, have you tried doing or performing some analysis? Yes. Anybody? Anyone? If you have tried calculating or analyzing some parts or simple beam calculations or any calculations? Hmm? On that day, you said like some of you have installed the Ansys, right? Okay, no issues. So it will take still little bit time to solve. So yes, I have already shown you the results like this. So maybe I had somewhere over here. So this is exactly the similar problem. I have solved it earlier with maybe some small distance and maybe with some small time than this. So with that, you can see such kind of results I had. Okay. So yes, I think we have completed this session. So session number 9. Maybe I am interested now to check what is there in our last uh, one. Okay, so this is related to equivalent radiant power. Hmm. Okay, I think this session will not take that much time because we have only three problems. So maybe half hour or 1 hour. Maybe we will include some theory part. 1 hour will be enough for this. So no need to have 2 hour session for this one. But yes, actually, I tried calling Ajay, but I wasn't able to contact him to decide the timings for this session. So whether we can do it today at evening or maybe in next week. So I wasn't able to contact him. So maybe he will let you know, or some of you can just tell him, like as per your free timings. Then we can arrange this last session, and it will, I think, only take 1 hour. So 1 hour will be enough for this. And maybe if you have some questions or that part also we can take up in that last session. Okay. Let's just see one more time whether it has solved or not. Okay. Okay, then there is no point. Maybe if it gets solved in last session, I'll simply show you its results to you. Mm-hmm. So yes, hence we have completed the 9 sessions. So only one left, that too on radiant power. So we will see that. And but before that, I need to talk with Ajay. I have to just schedule it as per maybe your free timings, and let's see how it goes. Hmm? So just maybe host. You can simply ask Ajay as per your timings, and you can tell him whenever it's possible to have that 1 hour session. So we can conduct that on that time. Hmm? So maybe one of you can simply have, or your coordinator, he can have a discussion with Ajay, so we can decide that session time. Okay, then yes, if it gets solved, I will show you these results in our last session. So till then, yeah, I will say practice, and yeah, practice. So it will only give you some confidence of this kind of calculations, and yeah, try to have some thinking related to this, and maybe in your last year, some projects or something you will be going to do. So try to use such kind of things over there, so that will give you extra benefit. So yes, so whatever apart from your daily curricular activities. So if you add this kind of steps into that, so it will be always good. Okay, so I think we stop for the day, and maybe if you have any questions in between also, you can ask me. Maybe maybe in last session, I can give you my email ID or my contacts, so that if you get across any queries or something, you can ask Ajay also, or you can directly ask me also. So there is nothing to hesitate. So I'm here to solve all your doubts and all your queries. So okay, thanks for bearing me for maybe last 1.5 hours. So uh, thank you for listening me patiently. And yeah, if you do not have any questions, I think then we can stop over here. I wish you a good day ahead, and see you on the only remaining session. Bye bye.
Okay, sir.
Yeah, welcome. Thank you.